All right, guys, we have a very exciting lesson today. We are going to learn about the derivatives of exponential functions, and in particular, the function e to the x, but we are going to talk about the other ones. So just recall with polynomial functions, all of the derivatives were a degree less. What might the derivative of an exponential function look like? Well, we are going to find out. So we're going to start off by first principles to figure out what the derivative of e to the x is. And no, you do not have to know this, but I'm going to show it for your enjoyment. So here we go. So we're going to start off and rewrite this. Okay, that's supposed to be an h, not an n. Okay, that's an h right there. Okay, and we're going to write it as e to the x times e to the h, that's exponent laws, minus e to the x all over h. Okay, next we are going to common factor out the e to the x, and since it doesn't have an h, it's not affected by the limit, so we can bring it to the left. So we're going to have e to the x, factor that out, and we get the limit as h goes to 0, and we get e to the h minus 1 over h. All right, so now we're kind of stuck here because we can't actually figure out what this is. I mean, you can plug in numbers close to 0 to sort of approximate it, but let's actually figure it out. So to do that, we're going to say let y equal e to the h minus 1. Okay, now we're going to just rearrange this a little bit so we get that y plus 1 equals e to the h, right? And then we're going to take the ln on both sides, and we're going to get ln of y plus 1 is equal to h. Nice. Now, we're going to replace this stuff in the limit, but first we're going to just look here as h goes to 0. So we're going to look here as h goes to 0, e to the 0 goes to 1, 1 minus 1 is 0, so y also goes to 0. So now when we write the limit, instead of putting h goes to 0, we're going to write y goes to 0 because our limit is only going to have y's in it. All right, so we get e to the x limit as y goes to 0 of y over the ln of, put it in brackets, y plus 1. Okay, still not much we can do. Oh, let's try that again. All right. Okay, now we're going to do a little trick here. Okay, we're going to bring the y to the denominator. Okay, but when we do that, we got to write it as 1 over y, right? Okay, so we're going to get e to the x limit as y goes to 0. We're going to have 1 over y ln y plus 1. All right, it's getting good. Oops. Okay, I don't know what's going on. Okay, so now what we're going to do is we're going to use our logarithm laws here. And we have the limit as y goes to 0, 1 over, now I'm going to bring the 1 over y and put it as an exponent over here. So we're going to get ln y plus 1 to the 1 over y. All right, now this might start looking familiar to some of you. Okay, what I'm going to do now is I'm going to say, all right, let y equal 1 over n. This will help it look more familiar. Okay, let y equal 1 over n. Now, as y goes to 0, okay, what happens to n? N must go to infinity, right? So what we're going to do here is, because 1 over infinity is equal to 0. So we're going to put, we're going to rewrite this now, and we're going to say that the derivative is now equal to e to the x. Now the limit as n goes to infinity, 1 over the ln of, I'm going to write it like, just switch the order here. Okay, and we're almost there. Now, this is a rule that we've never learned, but what we can do here is we can bring the limit actually inside of the ln, and we're going to do that. So we're going to get e to the x times 1 over ln of the limit as n goes to infinity, 1 plus 1 over n to the n. Wait a minute, what is ln of n goes to infinity, 1 plus n to the n? That's from yesterday's lesson. That is e. So this is by definition, by sort of not quite definition, but so e to the x times 1 over ln of e. And the ln of e is 1. So we get e to the x times 1 over 1, which is just e to the x. That's right. The derivative of e to the x is e to the x. So if y is equal to e to the x, then the derivative is also equal to e to the x. All right, this has huge implications, as we'll see a little bit moving forward. Okay, it's the only exponential, it's the only function whose derivative is itself. All right, so now we're going to apply the chain rule. Okay, so if y equals e to some function of x, then the derivative is the original function times f prime at x. Okay, that's just the chain rule. Okay, so now we're going to apply the chain rule to determine the derivative of any exponential function, okay, of any base. So we're going to start off with y equals a to the x. And what we're going to do here is we're going to take the ln of both sides. So we're going to say ln y is equal to ln of a to the x. Okay, and now we're going to rewrite this. Remember, if we rewrite this in its exponent form, right? So it's like e to that equals y. So we'll write y is equal to e to the ln a x. Okay, I'll just do one other manipulation. Now I'm going to bring this x out front of the ln a. Okay, we're going to end up moving it back after, but let's just do it like that for now. E to the x times ln a. Because remember, ln a is just a number. All right, and now we're going to use our chain rule. So we have that the derivative is equal to the original function, which is e to the x times ln a, times the derivative of this right here, which is just ln a. Beautiful. Okay, just about done. So we're just going to rewrite this back into this form here. Okay, we don't have to really do this, but we will. Times ln a. And this is, I guess, sort of from yesterday's work. So e to the ln anything is just anything. So the derivative is equal to a to the x times ln a. Okay, and that's the derivative of any function. So it's like, it works for e to the x as well, because there's e to the x of e to the x times ln e. Ln e is just 1. Okay, perfect. All right, so differentiate the following. So first one is equal to 3 times the derivative of e to the x, which is just e to the x. Done. Next one, the derivative is equal to the constant, which is 5, times the derivative of this, which is 2 to the x times ln 2. Okay, and you can keep your answer like that. You can rewrite it as 5 ln 2 times 2. It doesn't matter. That's okay. Okay, because that's an exact value. It's equal to 1/3 to the x ln 1 over 3. And that's it. It's pretty simple today. All right, so the last one, we're going to revisit this problem that we see sort of like every section. Determine the equation of the line that is tangent to y equals 4 times e to the x at x equal 1. Okay, so remember what we have to do. We have to get our y coordinate. So we plug it into the function. So y is equal to 4e to the 1, which is just equal to 4e. The slope of the tangent is equal to the derivative, okay, at the value of x. So derivative is actually the same, right? So it's 4e to the 1, also equal to 4e. So now we figure out our b value. Y equals mx plus b. Y is 4e. M is 4e. X is 1 plus b, which means 0 must equal b. Therefore, the tangent is y equals 4e x. And that's it. Okay, now here's your assigned work. One of the questions is going to talk about determining the equation of a line that's perpendicular to the tangent. Remember, perpendicular lines have negative slopes. Enjoy.